So Assalamualaikum. Okay, so in this video, we are entering the new chapter. So this is in chapter 2, and chapter 2 we will cover about the solution of first order differential equation. Okay, so basically for this chapter we will learn the method how to solve the differential equation, and the method that we will use is a numerical approach. So they have two methods. Okay, they have two methods. So the first one is Eulers method. Okay, Eulers method. And then for the second one is a Runge-Kutta method. Okay, Runge-Kutta method, it can be divided into two. Okay, second order and fourth order. But for your syllabus, okay, for our syllabus now, we will focus on first order. So the name for this method is actually second order Runge-Kutta method. Okay, I use RK stand for Runge-Kutta. Okay, so they have two methods that you will learn in this video. The first one is Eulers method, and the second is a second order Runge-Kutta method. Alright, okay, so both method is a numerical approach, and we will use this method to solve a first order differential equation. Okay, so I will start first with the Eulers method in this video. For the next video, I will show you for the second one, Runge-Kutta. Okay, so basically for the Eulers method, for Eulers method, okay, so the first thing first that you need to know is the formula. Okay, the formula for the Eulers method. So here, this is the formula for the Eulers method. In general, is given by yn equal to yn plus 1 plus hf x n minus 1 yn minus 1. So this is the general equation or general formula for Eulers. So I will explain first what is y, what is x, and so on. Okay, basically x and y is a variable. Okay, it's a variable x and y. And then this is not n plus 1, this is n minus 1. Okay, n minus 1, n minus 1. Alright, so f here is a function. So means that like this or something like this, f x y. Okay, so this is a function, and fxy is also equivalent to dy dx. Okay, it's the same meaning lah. Okay, fxy is equal to dy dx. Okay, alright, so that's one is x, y, f. And then for h, what is h? Okay, h is a step size. Okay, step size, ataupun dalam kata senang, kalau nak senang faham lah, h tu adalah selang, is a gap. Okay, let's say you have an equation x, x is x, so the starting point is 0, the end point is 3, and your step size h is 0.5, for example. So that's mean the next, okay, this is the initial point, so from the initial point to the next point is the gap must be 0.5. From here, from the next point to the next point is also 0.5, so that is 1. So here is 1.5 until you reach 3. Okay, so this is the step size. Okay, h is step size. Alright, so now I will show you how to use the Eulers method through example. Okay, I will show you through example. Okay, let's say you have an example. Okay, example 1 here. Okay, use Eulers method to integrate. Okay, to integrate no integration, it's just to solve numerically dy dx equal to x cubed minus 2x plus 3 from x0 to x3 with the step size, of 0.5. Okay, and then the initial condition at 0 is y1. Okay, so this is the equation. The question. Okay, the question, and this is the function that you have. Okay, remember I said just now dy dx is also equivalent to fxy. Okay, alright. So now, okay, how to solve it? How to start it? Okay, so I suggest you to use a table. I mean, it's okay if you don't want to use a table, but it's like more proper and more neat. Okay, lagi neat lah, like must you use a table, and then instead of to avoid you from a careless mistake. Okay, so I start with the column n, and then the next column is my column. Oh, sorry. If I use a pencil, is okay? Okay. So the next column is Sn. The third column is Yn. So means that they have 3 columns that you need to prepare. So N, Sn, and Yn. Okay, so the first column is N. So N, we start with N0. And then that means here is at 0. And here also is Y, 0. Okay, so now our job now is to find out what is your X0 or X0. Okay, we call it X0 and also Y0 lah. Okay, for X0, okay, X0, not here means the initial point. So based on the sentence that you have here from the question, it mentioned that initial condition at 0. So means that your initial condition for initial X is 0. So and then it already said that your Y is 1. When at 0, Y is 1. So this is the initial X. Therefore, this one is your initial Y. So your Y0 is 1. Okay. So for the first one, you can get it the answer, or you can get it the value from the question itself lah. Okay. So now we proceed to the second one. So for now N1. So N1 means that we want to find out X1 and also Y1. Okay, so if you can refer back to the formula that you have is to find Y. I mean the formula is Yn equal to something, right? So means that we will use that formula to get Y. How about X? How to get an X here? So X is just refer to your step size. Okay, just now I draw a line X. So the initial is at 0. And you will end until X3. And then the step size here is 0.5. So that's means from the initial point to the next point is 0.5. And then the next one 0.5. You just add 0.5, right? So means that just now your initial is 0. So your X1 would be 0.5. Okay, how about X2? X2 will be 1. How about X3? X3 will be 1.5. Okay, you can see that the X is the gap between X is 0.5. You add 0.5, 0.5. Okay. Alright, so now back to N1. Okay, back to the N1. So you want to find Y1 here. Okay, for this one you need to use the formula just now. The formula Yn equal to something, right? So Yn. So therefore your N here is 1. So kat sini or here it will be Y0. Why Y0? Because the formula is N minus 1. Okay, N minus 1. Alright. Okay, so plus H. Your H, okay, we write H first, and then F, and then Xn minus 1. So means that Xn minus 1, your N is 1, right? So 1 minus 1 is 0. Same thing for Y. Okay, so now your job is to fill out all this with the value. So Y0, you get the value from here, 1. How about H? The value from here, 0.5. Okay, X0 is 0. Y0 is 1. So you already halfway. You didn't fully yet because of you still have F01. Okay, how to get the value for F01? Okay, back to this question, back to this sentence. I said that Fxy is equal to dy dx. Therefore, Fxy is equal to this equation. So now what we need to do is x represent x, 0 represent x and 1 represent y. So what you need to do is substitute these two values into this. Okay, so x 0, 0 minus 2 times 0, 0 plus 3. So your answer will be 3. So there's no y here, so tak perlulah masukkan y, so you just consider x. So masukkan 3. So now you will calculate here 0.5 times 3 is 1.5, 1.5 plus 1, so the answer is 2.5. Okay, so now you already complete for n1, so that's mean your x1 is 0.5, your y1 is 2.5. Okay, so how to get x2, x3 and so on, you just repeat the same procedure like this. I mean for x2 means that you will calculate y2. Okay, y2 equal to y1 plus h f x1 y1. So y1 you get it the value from here 2.5. Your h is still remain 0.5. So x1, okay, x1 is 0.5, your y1 is 2.5. So now what we need to do is you calculate this one, substitute 0.5 into this equation, and then you will get a new value. So then sum, tambahkan, so you will get the answer. And then you will repeat the same thing until you reach until you reach x equal to 3. Okay, so actually it's simple, but I mean you need to do a lot of work lah. Tak adalah a lot of work, I mean it's iteration kan, so dia kan iterate banyak kali until you get the value that you need. Okay, alright, so this is about Eulers method. Okay, so I hope that you can proceed all this. Okay, so you can check your answer because I'm using this textbook. Kalau you nampak lah, this textbook. Okay, so actually the answer you can get it from this textbook. Alright, okay, so till the next video I will explain on Rajputa. Okay.